Hello again, Nine. I hope you had a really lovely half-term break. Welcome back to today's first lesson of this term. Incidentally, it's also the last lesson on this topic, but for today's lesson, we're looking at testing gas. So we're going to learn today how you carry out tests for hydrogen, oxygen, carbon dioxide, and chlorine. So we're going to do 4 different experiments today. I'm going to do 4 different experiments and then show you how they work, and we'll talk about the theory behind them as well. To start with though, please, can you try and answer these 4 questions on last term's work? How do you calculate an RF value in chromatography? What are the steps to setting up a chromatography experiment? What is a pure substance? And what is a mixture? So pause the video now and answer those 4 questions. Okay, let's go through the answers. So number 1, RF value is the distance moved by the substance, so that specific ink or substance if you're doing an experiment using something else, divided by the distance moved by the solvent. So that can either be water or ethanol as the other solvent that's used most commonly. And then what are the steps to setting up chromatography experiment? So when we're doing it in a lab, you draw a pencil line 1 centimeter above the bottom of the paper and put an ink dot on it. All right, it needs to be pencil, not pen, for obvious reasons, otherwise that pen line will run. Then you need to put that ink dot on it, and then just fill the bottom of the beaker with water, and then you lower the paper in so that it just touches the water without the water or solvent, whatever solvent is, reaching that ink dot, and that solvent will then run up that paper. What is a pure substance? So a pure substance is one that is made up of just one substance. So that substance can either be an element or a compound. So you might have pure oxygen, or you might have pure water. So pure oxygen would just be oxygen molecules. Pure water would just be water molecules, so 2 hydrogens and 1 oxygen. And then what is a mixture? So a mixture contains multiple substances that are mixed together. An example might be an impure substance. And then the way to test whether it's a mixture or whether it's a pure substance is look at its boiling point or its melting point, okay? Because elements or pure substances have exact boiling and melting points. So if they don't have an exact boiling or melting point, then they are not pure. So let's get into today's lesson, testing for gases. So today we're going to be looking at 4 different tests. Test for hydrogen, oxygen, carbon dioxide, and chlorine on a small scale. So we'll be making these gases, and then I'll be showing you how we measure them. But we're going to talk about firstly the theory behind it. What equipment do we use? In these experiments as well, you may be asked to talk about safety. So for this one, goggles for eye protection, apron, hair tied back, must be standing while doing this experiment. The key one here is the goggles, obviously. So can you please get down this table, and you're going to be filling it in as I do the experiment. So we're testing for hydrogen, oxygen, carbon dioxide, and chlorine, and they're the chemical symbols. And so can you get down this table? You're going to need to leave quite a bit of space because you're going to need to talk about what the test was and then what your observation was during the test. So I'll be doing the tests and then showing you what the observations look like, but we'll also be talking through the theory of them before you watch me do the test. So pause the video and jot down this table. Okay, so the first one is hydrogen. So there's 2 different ways to do the test for hydrogen. I do it a slightly different way to this method, but you can use this method where you fill in the... So this has got zinc and hydrochloric acid. For me, I use magnesium hydrochloric acid, but it still does the same thing. It just creates hydrogen. So I use magnesium and hydrochloric acid to create my hydrogen. So they will react in here, and they go out the conical flask. And this is normally filled with water. So you fill this with water, And then when you create the experiment, this then releases hydrogen gas, which travels down here and starts to fill this. And so as it fills this, the water moves out of the test tube or the measuring cylinder. And so it fills with hydrogen gas. Then once that's all happened, you then test the gas. So you then remove that, and then you put a lit splint, at the neck of the tube, and you should hear a squeaky popping sound. Okay, so the test for hydrogen is called the Squeaky Pop Test, but if you just write that in a test, you won't get marks, okay? You need to describe how the Squeaky Pop Test works. So collect hydrogen in a test tube, put a lit splint at the neck of the test tube, and if it makes a squeaky popping noise, it means that hydrogen is present. So that is your Squeaky Pop Test. So you'll see that in a minute when we do all the experiments. Second test is oxygen. So in this one, we just have one test tube and we put some hydrogen peroxide in, and then we put some manganese dioxide in. And so hydrogen peroxide and manganese dioxide react together to form oxygen. So what we do is we light a splint, so it's on fire, and then we blow it out. And what you notice with this lit splint is that it's still glowing. So it's got a glowing splint. You then put the glowing splint into the mouth of the test tube. Now, because there's lots of oxygen present, that will relight the splint, or you'll at least see a bright flash of light, which tells you that there is oxygen present. Because remember, oxygen reacts with the lit splint and usually restarts the lit splint. But if not, it will just make that lit splint glow brightly. Then test for carbon dioxide. So this one's nice and easy. So we fill the test tube on the left with marble chips, which is calcium carbonate, and then we put hydrochloric acid in here. Now the reaction produces carbon dioxide. So what we do is we put a bung on the top once we've put the marble chips and the dilute hydrochloric acid in, and then we have a delivery tube that runs into a different test tube, and that different test tube is filled with lime water. Now lime water, once it becomes or detects the presence of carbon dioxide, it will turn cloudy. So lime water turns cloudy in the presence of carbon dioxide and will tell you that there is carbon dioxide present. So you can actually breathe on lime water to turn it cloudy as well. If you breathe on lime water enough, it will turn cloudy, because we obviously breathe out carbon dioxide as well. Okay, so lime water is the test for carbon dioxide, and it will turn cloudy when carbon dioxide travels through it. And then lastly, test for chlorine. What you do is you hold damp litmus paper over the mouth of the boiling tube, and it will change color. Okay, so your damp litmus paper will change color when you test for chlorine. So we use electrolysis, which creates chlorine gas, and then we hold litmus paper over the mouth of it, and that chlorine will change the color of the litmus paper, and you will see that during the experiment. So in the next 4 experiments, write down your results in that table that you have created, please.
So today we're going to do our first experiment. We're going to test 4 experiments and tests for gas. So the first experiment we're going to do is a test for hydrogen. So the experiment they suggest is you put hydrochloric acid in here, and then we put some magnesium in to the hydrochloric acid, and then that will react, releasing hydrogen. So then we put the bung on, and what we do is we collect the hydrogen in this test tube here. But the experiment does take quite a long time because there's quite a lot of air in this whole experiment. So what I'm going to do is cheat and do a shorter experiment. So in this test tube here, I've got some hydrochloric acid. I'm going to add some magnesium, and then I'm going to collect the hydrogen gas produced in this test tube up the top here. So what's happening here, hopefully, is we're releasing hydrogen, and then I'm going to collect it in this test tube here. Okay, so this is the Squeaky Pop Test, we sometimes call it. But don't just write Squeaky Pop Test in the test. What you'd actually need to write is that the reaction produces hydrogen, and then to test for hydrogen, we then put a lit splint in the mouth of the test tube, and it will make a squeaky popping sound. So what I'm going to do in a second is I'm going to light a splint, and then I'm going to check whether it's worked by testing the gas on this test tube. So don't uninvert it, because then the hydrogen will escape. I'm going to put my finger on this here, and then I'm going to light a splint, which is easier said than done when you've only got one hand. Right, here we go. Perfect. Right, splint, that's a lit splint. And then I'm going to insert the splint and then see whether we've got hydrogen inside. There we go. So that is the Squeaky Pop Test. And as you can see, this experiment is still slowly but surely filling with hydrogen, but I'm too lazy to wait, so that's a much easier experiment for hydrogen. We're going to do another test now. I'm going to test for oxygen. So what I've got in here is a little bit of manganese dioxide, and then in here I've got myself some hydrogen peroxide. So what happens when you add hydrogen peroxide to manganese dioxide is it releases oxygen. We're then going to test for the oxygen, because what it should do is relight my splint. So I'm going to have a glowing splint. It's not going to be a flame, but it's going to be red hot and glowing, and it should relight, because this reaction should create enough oxygen that if I add my splint to it that's red hot and glowing, it should relight. And there we go. As you can see there, that bright red flashing light, that's because there is oxygen being released in here. So it's trying to relight my splint. So therefore we have oxygen present. Third test now. So we're going to do our third test now, which is carbon dioxide. So what I've got here is some hydrochloric acid, and then I've got some marble chips, so calcium carbonate, and we're going to test to see whether it creates carbon dioxide. So I put my hydrochloric acid in here, and I'm going to add some marble chips. Now these marble chips react with the hydrochloric acid, releasing carbon dioxide. And the way to check for that, so if I lower them so they actually go in, is what's in here, which as you can see here is clear. But if I add it, so this is lime water, so we should start to get some bubbling. As the gas is released, it's going to push the air that was already in here through here, and then eventually we're going to start getting carbon dioxide coming through here. So carbon dioxide, it actually turns lime water cloudy. So this clear lime water we see here should very soon, once all the air and the oxygen is out, should start going clear. So if I can get more of my marble chips down into it, we should soon start to see our carbon dioxide going clear once the reaction has pushed all of the oxygen out from the test tube and then the bung and the tube itself. So as you can see now, it's starting to go cloudy white. So it's not clear anymore. It's starting to go this milky cloudy white color, which means that there is presence of oxygen. So it started out perfectly clear, and now, as you can see, it's now this milky color that we can see down here much clearer. So that means that there must have been carbon dioxide coming out of here. What we have here is an electrolysis test to check for chlorine. So what I have in this electrolysis setup here is sodium chloride. Okay, so it's got sodium and chlorine in it. And so what we're doing is we're using electrolysis. So we've got our positive anode and our negative cathode. And so because chlorine is the negative in the sodium chloride, it forms at the positive anode. So our check for chlorine at the end of this reaction, once we've caught all the gas, so we've got little test tubes on each of the anode and cathode in order to catch the gases. So once we've caught all the gas, what we're going to do is we're going to test it with some damp litmus paper. So this litmus paper should, if we do it correctly, should change color in the presence of chlorine. So we've got our damp litmus paper, just waiting till I've got enough chlorine. I'm going to just pull it out and then check to see my chlorine gas. and see whether my chlorine gas, and there you go, as you see, it goes clear with the presence of chlorine gas, proving that we were separating the chlorine into this test tube there. And then this one is the negative cathode. Okay, so we weren't interested in this one, we were interested in collecting the gas at this one here. So I put that back on, and that will continue to collect chlorine gas in this cathode here, anode here, sorry.
Hi, Year 9. I hope you enjoyed those experiments. Now, what I'd like you to do for me is now answer these questions on all of those experiments. So, number one, write a word equation for the reaction between magnesium and hydrochloric acid. So, have a think about what did I use it for, what test of gas was I using that for, and then obviously then that is going to be one of the products. So what is then left to be the other product? BI, explain why hydrogen pops with a lighted splint. BII, write a word equation for the combustion of hydrogen. So again, have a think about hydrogen plus what is going to form what plus what, all right? So it's obviously combustion. So combustion uses what element? 2A, can you then write a word equation for the catalytic decomposition of hydrogen peroxide? So have a think about, what did I use hydrogen peroxide for? What did I combine the hydrogen peroxide for in the experiment? And then what gas did I check for? So one is one of the products going to be. 2B, can you then explain why oxygen relights a glowing splint? 3A, write a word equation for the reaction between calcium carbonate and hydrochloric acid. So calcium carbonate plus hydrochloric acid forms what plus what? 3B, lime water's solution of calcium hydroxide in water. Explain why it goes milky when carbon dioxide is bubbled through it. So have a think about the fact of what the chemicals are. Why would it go milky when carbon dioxide travels through it? And then lastly, explain why litmus paper goes white when in contact with chlorine. So you might need to look some of these questions up if you're not sure about them. But pause the video now and have a go at answering these questions. So 1, the word equation, magnesium plus hydrochloric acid forms magnesium chloride plus hydrogen. You could use the chemical symbols there for the equation otherwise. Why does hydrogen pop with a lighted splint? The pop sound comes from the small explosion formed by the burning of hydrogen with oxygen. Okay, so it is an explosion or combustion where the hydrogen is burning in oxygen. The word equation for the combustion of hydrogen is hydrogen plus oxygen will form water. Decomposition reaction, or the word equation for the catalytic decomposition of hydrogen peroxide is hydrogen peroxide forms water plus oxygen. Okay, because it's catalytic decomposition. So remember, you've got the catalyst is not used up, so the catalyst is not part of the word equation. Why does oxygen relight a glowing splint? It's because when glowing splint is introduced in the test tube, it bursts back into flame when in contact with oxygen. Because remember, oxygen, if you add pure oxygen to a fire, it becomes much stronger. Remember, there's only about 21% oxygen in the air. So if you've got pure oxygen, there's going to be far more collisions, because remember, there's a higher concentration, so therefore far more successful collisions. So that's why it relights that splint. Word equation for calcium carbonate and hydrochloric acid is calcium carbonate plus hydrochloric acid forms calcium chloride plus water plus carbon dioxide. Calcium dioxide turns lime water milky due to the formation of insoluble calcium carbonate. So that's why you can't see in it. It's got calcium carbonate inside of the water and it doesn't dissolve because it's insoluble, which is why that lime water turns cloudy. And then chlorine is actually bleach. So chlorine bleaches the litmus paper. So it goes from blue to white because the chlorine is literally bleaching the paper. So give yourselves a score, please, on that, just to see how you did with those questions. Okay, if you are in the grammar stream and you've got time left in the lesson, have a go, please, at these questions here. So read through these questions, have a go, and see if you can answer these. So I hope you have enjoyed that lesson, year 9. In conclusion, so tomorrow we're going to do a live revision lesson of this topic. Wednesday, you're going to have a chance to revise yourself during the lesson. So we're going to, Miss Callis and I will put a lot of revision resources on EduLink for you. Otherwise, you can do your own revision. And there'll be some questions on SAM Learning as well. You're going to do your test on Thursday, so we'll send out that test. And then on Friday, you will be doing the live marking of that test. So make sure you do your test on Thursday so that you can come on Friday and we can mark it all and see how you've gone. I know it's a short topic and it's been split over the half term, but you guys will be absolutely fine with it. And so, yeah, make sure you're doing the revision this week so that Thursday you do really well on your test, and then Friday we'll mark it. Take care, guys. Thank you very much for watching.